Everyone, welcome back to my channel. So far we have already explored some amazing machine learning algorithms like decision tree and support vector machine regression or classification. But today we are diving into the a new, let's say, advanced machine learning algorithm, which is, let's say, a more powerful algorithms that take the simplicity of decision trees and handle a complex problem with easy. So this is a random forest. I'm quite sure maybe you already heard about this. And imagine that you are, let's say, lost on in a forest, and you would like to find your way. So if you ask just one person for the directions, they might he might, let's say, lead to give you a wrong direction. But what about if you ask hundreds of people and take the most popular route? So it chances that you will find the right path. This is exactly how the random forest. And sometimes it's happened for me when I landed in a new city, and I ask for instance someone for the direction, and after a while, just maybe 1 minute, I will ask the second one, where's the direction? And just to me to be quite sure, because sometimes you will get lost if you didn't ask. And that's why I'm asking, let's say, two three persons, and if the answers are similar, I will see, yeah, this is the right direction. If there's a conflict, I will just take the most, let's see, the foot, let's say, foot method. So so now in today's video, I will explain how the random forest is working, and of course with Python code. And I will also upload the video and also the code. So please, if you like the video, please subscribe to my channel, like the video, and if you have, of course, any question, drop it down in the comment below. I will answer it. So this is, let's see, the outlines. So I will this is define the random forest, understanding the decision tree. This is we already covered in the last video. I will put the description in the I mean the link in the description, and how does this work, and step by step numerical example, and of course advantage and disadvantage. And I will also provide the code. And as you can see here, for instance, this is your data. This is taken from this website. You have this data set here, and you will try to build several decision trees, but in random, not on the whole data set, but in random, let's see, data. So this, for instance, tree will work on will be built on different, let's see, features or and rows, and this also will be built in different features or maybe rows. So I will say there's no, let's see, similarity between these data sets that used in each tree. This is the goal, let's see. And why we have, if you just remember from the decision tree, what the one the main disadvantage of decision tree is that we only build one tree for the whole data set, and this will lead to, let's see, overfitting. The overfitting is that the model will start to keep the memorize the data, and not make it generalized. But here, if you see, we have different trees and trained on different subset of the data set, and that's why we will try to reduce or remove the overfit. So, and in the random forest, it's, of course, it's a machine learning, and it's supervised learning used for classification or regression. And let's say that we have this data set here, a student, and from 1 to 10, and they have studied our attendance, previous exam score, and we will try to predict if he pass or fail. So based on this, we will try to create, let's see, bootstrap samples. Bootstrap, it's like decision tree, it's called bootstrap. But random forest use, as you can see, random forest use bagging. What is bagging? As I said, bagging, if you have many options, in one hand, in your hand, and you will select, let's say, the most accurate one. So this means we will create multiple sub decision trees. For instance, let's see we have three different three decision trees. So as I said, it's called bootstrap. So one, two, three, and as you can see here, for instance, we have this data set, and for instance, the first data set will be trained on this, let's see, rules. For instance, one, two, three, four, five, till 10. And sometimes it will also, you will see some rules are repeated, maybe repeated. For instance, they will use one, one, two, three, three, four, five, five, and etc. This is because it's random. And for the second decision tree, I will take this one here. You can see it's randomly taken, and also this. And with this example, we'll try to build a decision tree. That's we already covered in the, as I said, in the previous video. And you could also not only randomly selecting the data set, subset of the data set, but also you can select random features, select random features. For instance, for the first tree, I will try to choose this and this, for instance, hours studied and attendance, and this will be ignored. And of course, class label will be used in each tree. And after, let's see, building the decision trees, now we would like, let's see, to predict, to make a prediction on this, for instance, on this data here. So we have our studied attendance, previous example, because I haven't built the each decision tree because it takes much time to build this. But the main idea is just to give you overview how this is working. And now let's see, we have three decision trees, and let's see all these trees are, let's see, this is a prediction pass fail, and because of this, I will try to aggregate the prediction and select the most, let's see, popular one, or let's see, use majority voting, because here pass is more than fail. I will try to classify this data here as a pass. And yeah, this is, let's say, a key points of to remember. Maybe it will be used in be as a questions, how the decision tree is used to remove or eliminate the overfitting, because it uses many multiple trees, and each tree is trained randomly on a subset of the data or maybe a subset of the features. And the advantage, I mean, advantage is reduce overfitting, handle missing data. So what does that mean, handling missing data? So if you remember, in each data set there might be missing data, right? And you would like to remove this data by filling this data with any data, any not random data, but maybe taking the mean or median, and replace the missing with these values. But for the random forest, it's not needed here. It will be automatically. For instance, let me just assume this. I have this hour studied, and let's assume this is empty, or let's say missing value for decision tree. It will try to see, will I be able to classify this without this missing value? If I have many missing values in this column here, it might be removed because it's randomly it work with some features. It might be removed, or maybe use the other one with more high important as a root. You can see decision tree taking the it use the select the entropy and the information gain to select the root of the tree. And I think this is enough for the theory. Let's see. And here I have the implementation. The implementation is similar to what I have in the document. So the same data set. It's just make to make it simple for you, and you can let's see, debug and see what is going on. And for the next video, I will show you how to use random forest in a real data set, let's say for spam detection or any other problems statement. And you can see here, this is the data, our data set that used in the document. And here I have the decision tree. Yeah, here's the decision tree. And number of estimators is this number of, let's see, decision trees. And we use this random state just to make the result reproducible every time. So if you run this one time, two, three, 10 times, you will get the same result. But without this, you will get different result because it's randomly selected. And yeah, I think that is enough for today. Of course, I will push the document, the code and video. And yeah, if you like this, please subscribe to my channel because preparing this document, it took a lot of time. Thanks for watching and see you next time.